vertical and horizontal translations. When we talk about translations, we're talking about movements that you make in a graph. And in this particular video, we're talking about shifts. When we move a graph and its position, but we don't change the shape or the size of the graph. So we're going to work with just a basic parabola here. You can work with any basic function. We're just going to work with a parabola. F of x equals x squared. Here is the function x squared. If we add a 3 to the end of that function, for now it's x squared plus 3, what happens to the graph is that it actually shifts 3 units up. It's like if you pick this graph up off the page and move it 3 units upwards. So you can see that on the graph, and you can also see it when you look at the ordered pairs. The y values from this graph and the y values from this graph are 3 units difference. If you add 3 to the y's from the first function, I would get the y's from the second function. So adding 3 moves the graph up 3 units. So what do you think would happen if you subtracted 3? Well, it would make sense that if you had had y equals x squared minus 3, your graph would shift down 3 units. And that is, in fact, what would happen. We can also shift a graph side to side. So we'll start with our same basic parabola, f of x equals x squared, where it starts with the vertex of that graph being right there at the origin. But this time, instead of adding 3 to the end of the function, I'm going to add the 3 where the x is. Since the x is being squared, I want to add the 3 in before it is squared. So it's actually x plus 3 in a set of parentheses squared. This has the effect of moving the graph to the left. Now you might have thought since it was plus 3 that it would move it to the right, but actually when we're talking about the horizontal shifts in a graph, it's going to move the opposite of the direction that you think it's going to move. A positive 3 would actually move it to the left. If I had had the graph y equals x minus 3 squared, it would have shifted my graph to the right 3 units. And you can tell that when you look at the ordered pairs. The x values, to get the same y values, the x values just had 3 subtracted from them. So this is summarized in this table. If you have a function f of x and you've got a constant that is a positive number, if you add that constant to the end of the function, it's going to shift the graph up or down. If you add or subtract that constant inside where the x goes, in other words, whatever is being done to the x is also being done to that constant, that is going to move the graph to the left or to the right. And on these, it's going to happen really in the opposite of the direction you think. If you're subtracting the number, it will move it to the right. If you're adding the number, it will move it to the left. So let's write an equation. If we have the function f of x equals the square root of x, and we want to shift that 5 units down, my new function would be, let me call it g of x, the square root of x, then I would have a minus 5 at the end of that function, because a downshift would go at the end of the function 5 units. It would be subtracted, and you would use a 5 with it. The second function here, I have 2 moves I want to make. I want to move it 4 units to the left, and I want to move it 7 units up. Well, let's start with 7 units up. 7 units up means I'm going to, at the end of my function, I'm going to stick a +7. Since it's up, it's a positive move. Now, 4 units to the left is going to have to go wherever the x is. So it will go in parentheses with the x. Now, when I move it to the left, that is actually going to be a +4 that's going to go in there with the x. So this new function, g of x, would have inside the absolute value bars 4, then parentheses, x +4 minus 1. And then on the outside of the absolute value bars, I would have my +7. Now, let's look at one more where we're going to actually make the graph and write the equation. Here we're dealing with the basic function f of x equals x cubed. This is what an x cubed function looks like. Okay. It kind of goes through the origin of the graph right here. Okay. Here are the points that you can use to graph f of x equals x cubed. What I want to do is shift this graph 3 units to the right, and I want to shift it 2 units down. So I'm going to play with my ordered pairs here. If I shift it 3 units to the right, what that's actually going to do to my x coordinates is it's going to add a 3. Now, what it's going to do to the y to shift it 2 units down is I'm going to subtract 2. Now, I don't want to graph this first ordered pair or this last ordered pair because those numbers are too big. Let's just work with these ordered pairs right here. If my x starts out at -2 and I add 3 to it, that's going to give me a new x coordinate of 1. If my y starts out at -8 and I subtract 2 from it, that's going to give me a new y coordinate of -10. Okay. So the point that was -2, -8 is now +1, -10. Let's take the -1, -1. If I add 3 to the x, that'll give me a 2. And then if I subtract 2 from the y, that'll give me a -3. So here I have the ordered pair 2, -3. 0, 0. If I add 3 to 0, I get an x coordinate of 3. If I subtract 2 from 0, I get an x coordinate of 2. So that's the point 3, -2. Then 1, 1. If I add 3 to 1, I get a 4. And if I subtract 2 from 1, I get a -1. So that's this point. And finally, one more. 2 plus 3 would give me a 5 for the x coordinate, and 8 minus 2 would give me a 6 for the y coordinate. So that would be the point right here. So my new function is going to have this kind of shape to it. Same graph, it just is shifted. It started out kind of being centered right here, but it shifted over 3 units and down 2 units. The equation for this new function would be, let me call it g of x equals x minus 3, because a shift to the right means your function would have the minus 3 in it. So x minus 3 cubed minus 2.